So the next section of chapter 2 is about units, and units are important. Oftentimes you have a quantitative measure, so it's a value, and the unit that it's in, so that's the scale of measures. The example of that is not just 10, but 10 centimeters. And so the other thing that I could talk about in chemistry, so we sometimes have letters that are variables, and so that would be like an X in math, and so that X might equal 10 centimeters. So this is the quantitative number, the value. That's the magnitude of the thing. And then the units behind those letters are the scale of it. And so examples that are common in science would be grams, so 6.7 grams, 15 centimeters, 4 hours, 87 degrees Celsius. And so these ones are written out in words, but we often just have a letter that represents those units. And in this course, it doesn't matter. In the last video, I said it doesn't matter whether you write it in standard or scientific form, but it really does matter. You always need to include your units in your answers. And so there are different scales. Mostly we use the metric system in Canada because of our proximity to the States and the fact that they use the imperial system of measure. We do have some things, like I don't know how tall I am in centimeters, but I do know how tall I am in feet and inches. And so we have a bit of a blend in Canada, but in the world of science, we purely use the metric system. There are agreed upon units, and they're the international system, or SI, and those letters are backwards because it's the Système International. It was in French, so they're the SI units, and they're kind of the standards. In the world of science. They are, like I say, all metric, and they do kind of unify the world of science and chemistry across the world. And so these are the SI units. Now, some of them are not always useful. So as an example, the standard unit for mass is kilograms, and yet in chemistry, because we use such small things, typically we use grams. Meters are pretty big, but we still generally use them, not so much in chemistry, but more in physics. Kelvin is a measure of temperature. That is the standard unit, or the Système International unit. But we also have another metric measure, which is degrees Celsius. And so that might be what you're more familiar with. The mole is maybe the biggest concept in chemistry. So it's super important. And we'll get more into that when we get into the second half of this course. There's another one that's missing here, so volume. The standard is liters, which again is sometimes inconvenient for the world of chemistry because in the lab, we're not dealing generally with liters of solutions. We're more likely milliliters of solutions. So as an example, milliliters and liters, or grams and kilograms, have prefixes on the base unit. So as an example, we could talk about base units in the world of science. So it has no prefix. So a base unit might be the meter, right? That's the base unit. And then because that's not always convenient, we'd also have kilometers, we'd have centimeters, we'd have millimeters. So the letter out front, those are the prefixes that make them either bigger or smaller than that base unit. Other ones that you've seen would be liters and milliliters. There's a lot of prefixes, and not all of them get used in our day-to-day life. So let's take a look at the metric system. I can't even believe that I typed out that I call this the slidey chart. I really do. You might not want to talk to other people about the slidey chart because they might not know what you're talking about. But illustrating the metric system this way shows that you have your base unit here in the middle. And so that would be liters, grams, meters, all of that kind of thing, right? With just one letter. And then over here, you would have your centimeters, you'd have your millimeters, right? Those would be really small things. And they go all the way over to like things that you would use in cell biology, like nanometers or micrometers, right? For those really small things. Up on the other side, again, you have other prefixes. So you would have kilometers, or megameters or gigameters. I don't even know when we use that. But up here, these really, really big things, you can think of, storage on a computer device, right? You have giga or megabytes of memory or storage. And so those are all examples of this slidey chart and how it has the base units in the middle and then those different prefixes on either side. And so I like this orientation of it because each space along this slidey chart represents a decimal place different. So over here, you're dividing by powers of 10. And over here, you're multiplying by powers of 10. And so if you want to make a conversion in the metric system, you can really use this as a roadmap. And so I'm going to make my page a little bit smaller so you can still see this slidey chart. And I'll do some examples down at the bottom. And so if we do some examples down at the bottom here, maybe I'll just make it a little bigger. There's one that's typed out, but I like using this as kind of a written in example. So let's start with the example that we want to move from 4.2 meters into how many centimeters. So to use the slidey chart, and you sure can just multiply or divide by powers of 10, but this approach is a little less mathy as an introduction to kind of warm you back up into the world of the metric system and math. You're going to start at meters and you want to go over to centimeters. So you just simply count how many spaces, because each space is a decimal place. So you'd move it 1, 2 places that way. So this is where the decimal place is starting, and I'd move it 1, 2 places. That's where the decimal place is going to end up in my answer. So you can kind of read my bumpy writing here. That's 420 centimeters. Let's take a look at another one. What if I wanted to do 4.2 meters and represent that in the unit of millimeters? So again, I'd start with the meters because that's where I'm starting. And I want to convert all the way over to millimeters, that prefix M in front of the other M. So I'd go 1, 2, 3 places that way. So it's starting here and I'd go 1, 2, 3 places. That's where my decimal is going to end up. And I'd fill in my little bumps with zeros. So that's 4,200. There's another one we could do. Maybe we have to go through that base unit. So the last one that I might show us, what if we were to convert, and this one's kind of ridiculous. I don't know what useful application you'd have. What if you had 0.2 kilometers and you wanted to figure out how many millimeters that would be? So in this one, if we're starting in kilometers this time, then we want to count how many spaces, because that each one is a decimal place, over to millimeters. So 1, 2, 3, 4, 5, 6 that way. So we'd move it from there, and then we'd have 5 zeros behind it. So 200,000. At the top of the page, there are some more. You can always represent your answers in scientific notation, or if you are using the slidey chart, I feel like it lends itself to representing them in standard notation. So there's 6 at the top of the next page, and what I'm going to do is just put the answers up. They take a minute probably for you to do and make some sense of, but as you work through, see if you can use the slidey chart. If the slidey chart doesn't work for you, it doesn't resonate with you, we can always do these, like I had said, by multiplying and dividing by powers of 10. I just have chosen not to show that in this video to give you one way as opposed to 2 different ways. But with math, there's often multiple ways to get to the right answer. And so long as you have a process that works for you, like I'd said in chapter 0, the process, the strategy of problem solving is usually more important than the actual answer, I think. So sometimes, like I said, you go the wrong way. If I ever make a mistake in these videos, just let me know, because nobody's perfect. And I certainly never do it on purpose. All right, so maybe you remember the metric system. That gives us a little intro to it. Remember to always include your units. They're always important when you give your answers in chemistry.